Hello all, I am Dr. Prabhas Sanjanbal. In today's class, we'll discuss about the complexity theory or P class, NP class like this. Okay. So now we'll see the definition of what is the meaning of P class and what is the meaning of NP class. See here, the first definition is P class. The first definition is P class. What is the meaning? The definition of P class is the set of languages which are decided by deterministic Turing machine in polynomial time. Okay, the set of languages which are decided by deterministic Turing machine in polynomial time, these languages are called as P class. Okay, or some another definition you can say the set of problems which are solved by using deterministic polynomial time algorithms. The set of problems which are solved by using deterministic polynomial time algorithms known as P class. So there are two definitions. We can use any one definitions. Okay. So the P class means the set of languages which are decided by deterministic Turing machine in polynomial time. This is called as P class. Okay. Now we'll see NP class. Now we'll see the definition of NP class. The set of languages which are decided by non-deterministic Turing machine. The set of languages which are decided by non-deterministic Turing machine in polynomial time. This is called as NP class. But P class means the set of languages which are decided by deterministic Turing machine in polynomial time. But NP class means the set of languages which are decided by non-deterministic Turing machine in polynomial time. This is called as NP class. One more definition we can see the set of problems which are solved by using polynomial time non-deterministic algorithm is known as NP class. So finally we can define both definitions. P class means deterministic Turing machine and NP class means non-deterministic Turing machine. This is the main difference. So for P class problems, we will solve using deterministic Turing machine in polynomial time. For NP class, we will solve the problems using non-deterministic Turing machine using polynomial time. Main difference is deterministic Turing machine for P class, and for NP class, we will use non-deterministic Turing machine. This is the main difference. Okay. The next concept here, for any language, if halting Turing machine exists, HTM means halting Turing machine. For any language, halting Turing machine exists. The halting Turing machine will divide the halting Turing machine in two parts. One is DTM, one is NTM. DTM means deterministic Turing machine. DTM means deterministic Turing machine. But NTM means non-deterministic Turing machine. Okay, DTM means deterministic Turing machine, NTM means non-deterministic Turing machine. Okay, so deterministic Turing machine will divide the HTM in two parts. One is the deterministic Turing machine, another one is called as non-deterministic Turing machine. For deterministic Turing machine, the class exists, means this is called P class or DP class. P class means polynomial class, or DP means deterministic polynomial class. DP DP means deterministic polynomial. Deterministic polynomial. Polynomial. Or simply we can call it as P class also. NP class means non-deterministic polynomial class. Non-deterministic polynomial. Okay, so P or DP means polynomial or deterministic polynomial class. NP class means non-deterministic polynomial class. Okay, so some examples of P or DP class means deterministic polynomial class. Searching. MM means matrix multiplication. CYK algorithm, we have already discussed about the CYK algorithm in the previous classes. Okay, some examples of NTM means non-deterministic Turing machine or NP class problems. Which problems are belongs to NP class problems? The NP class problems are 01 knapsack. TSP means traveling salesman problem. Okay, these are the problems for NP class problem, and these are the problems for P class or DP, we can say, means a deterministic polynomial class, or we can say polynomial class. Okay, so P class means the problems that are related to P class or DP class, like sorting, searching, matrix multiplication, CIK algorithm. These are the some examples of polynomial or deterministic polynomial class. But NP class, the examples of NP class like 01 knapsack, traveling salesman problem, like this. These problems are belongs to NP class problems. Okay, so we have already discussed about the definitions of P and NP class and some examples of P class and NP class. Okay, so now we'll see the next concept. P means polynomial class equals to non-deterministic polynomial class or not. So P equals to NP class, is it true or false? Now we'll see. Okay, now we'll see the important concept. P equals to NP, yes or no? P equals to NP, yes or no? So first definition, or the first one, every P class problem is NP class, but every NP class problem need not be P class. So we can write like this: every P class is a subset of every NP class. Every P class is a NP class, but every NP class need not be P class. Okay, so this point is clear. Every P class is NP class, but every NP class need not be P class. Okay, next point. The P equals to NP means P class equals to NP class happens or not is an open question. Means we don't know P equals to NP as true or false. Either P equals to NP or P not equals to NP, we don't know. So that's why it is a very open question. P equals to NP, yes or no? Okay. So the next point, for at least one NP problem, if we construct deterministic polynomial algorithm, for at least one NP problem, if we construct deterministic polynomial algorithm, then for all problems of NP class, deterministic polynomial time algorithm exists. Okay, so for at least one NP problem, if we construct a deterministic polynomial algorithm, then we can construct for all problems of NP class, we can construct deterministic polynomial time algorithm. Okay, this is very, very important. But till today, none has proved this. Means this part. Means none has proved non-Hutch proof, like nobody can prove, means nobody can construct a polynomial time algorithm for construct a deterministic polynomial time algorithm for a NP class problem. Okay, so but till today none has proved this, means this part, none means none has proved this. But and we cannot even say deterministic polynomial time algorithm not possible for NP class problems. Okay, none has proved this part. Nobody has proved this part. But we cannot even say deterministic polynomial time algorithm does not exist or not possible for NP class problems. Okay, so these are the very important. So that's why hence P equals to NP is an open question. Hence P equals to NP open question means we don't know P equals to NP as true or false. Okay, now we'll see the closure properties of P and NP class. Now we'll see the very important, the closure properties of P and NP class. See, P and NP both, P and NP classes are closed under, P and NP classes are closed under union operation, concatenation operation, intersection operation, clean closure operation, positive closure operation. So P and NP classes both are closed under these 5 operations, means union, concatenation, intersection, clean closure and positive closure. So all are P and NP are closed under these 5 operations. Okay, so now we'll see the 6th one, complement operation. Now we'll see the complement operation. Now we'll see the complement operation. See the point, P class is closed under P class is closed under complement operation. P class is closed under complement operation, but the complement of NP class is an open question. But the complement of NP class is an open question. So NP equals to complement, its complement yes or no, we don't know. So that means if P equals to NP happens, then we can say that its complement exists yes or no, we can say. Okay, so that's why P class is closed under complement operation, but we cannot say the complement of NP class exists or not. We cannot say the complement of NP class exists or not. Okay, so if P equals to NP happens, we can say that its complement means the complement of NP class always exists. We can say that. So that's why the complement of NP class is an open question, since P equals to NP is an open question. That's why the complement of NP class is always open question. Okay, this is also very important. So P and NP classes are closed under union, concatenation, intersection, positive closure, clean closure. But P class is closed under complement operation, but the complement of NP class is always a open question. Okay. See the problem reduction. We have already discussed about the problem reduction in the previous classes. Okay, again we'll discuss here. What is the meaning of problem reduction? Say a problem A is reduced to problem B. A problem A is reduced to problem B means what? We can conclude the problem B. We can conclude the problem B with the help of problem A. A problem is reduced to problem B. That means what? We can conclude the problem B with the help of problem A. Okay. So the next point, this reduction requires polynomial time. This reduction means A reduced to B. This is a reduction. This reduction requires polynomial time. Hence, it is also known as polynomial reduction. Means this problem reduction is also called as polynomial reduction because it requires polynomial time. Okay, so now we'll see the reduction process. If A reduced to B, we can say that if B is polynomial class, then we can say that A is polynomial. Okay, if B is polynomial, then we can say that A is polynomial. This is very, very important. Okay, similarly, if B is NP class, we can say that A is NP class. If B is NP class, we can say that A is NP class. Okay, so if B is P class, A is P class. If B is NP class, then we can say that A is NP class. This is very simple. Okay, so third point, if A is P class, this part, if A is P class, we cannot conclude P class. Because if B is P class, A must be P class. If A is P class, we cannot conclude P class. Similarly, if A is NP class, we cannot conclude about NP class, because if B is NP class, we can say that A is NP class. If B is NP class, we can say that A is NP class. Okay, but if A is NP class, we cannot conclude about NP class. So the next point, see the fifth one, polynomial reduction satisfied the transitive property. Polynomial reduction or problem reduction is always satisfy the transitive property. What is the meaning of transitive property? If A is reduced to B and B is reduced to C, then we can say that A is reduced to C. Okay, so polynomial reduction always satisfies transitive property. If A is reduced to B and B is reduced to C, then we can say that A can be reduced to C. Okay, so this is the end of today's class. Also about P and NP class. In the next class, we'll discuss about the NP complete problem and NP hard problem. Okay, thanks for watching.